Hello everyone, this is Abebe Chukala from IHE Delft. This lecture video demonstrates how the protocol can be used to assess performance indicators such as uniformity, efficiency, adequacy, and relative water deficit. The seasonal water consumption, such as actual evapotranspiration, seasonal transpiration, and seasonal potential evapotranspiration, which are calculated from WaPOR datasets and local information, can be used to calculate WaPOR-based performance indicators, such as uniformity, efficiency, adequacy, and relative water deficit. This module demonstrates assessment of uniformity, efficiency, adequacy, and relative water deficit. Uniformity measures the evenness of water supply in various portions of a field. It's calculated as a coefficient of variation of seasonal actual evapotranspiration in the area of interest. Efficiency or beneficial fraction is calculated by dividing seasonal transpiration to seasonal actual evapotranspiration. Adequacy is calculated as the ratio of seasonal actual evapotranspiration over potential evapotranspiration. Relative water deficit is calculated by subtracting the ratio of seasonal actual water consumption over maximum actual evapotranspiration from 1. There are 4 main steps to run this module. Firstly, make sure the input data to the module are ready. That is, the preceding module is complete. Secondly, launch the Jupyter Notebook. The simplest option to open the Jupyter Notebook is start with opening the WaPOR WP master folder, which is downloaded from the GitHub repository. In the open folder, in its address bar, type Jupyter Notebook and press Enter key. That leads you to open Jupyter Notebook environment. Then, thirdly, open Notebooks folder, and it shows all the modules in the protocol. Finally, run the module. From the launched Jupyter Notebook, click on the Notebooks folder, and then to run Module 3, click on it. Module 3, which helps to calculate performance indicators such as uniformity, efficiency, adequacy, and relative water deficit, has 5 main steps. It starts importing modules library and data, and then creates output folder, which is as part of setup step, then followed by calculating uniformity, efficiency, adequacy, and relative water deficit. So we start importing the package standard libraries which are built in Python. So to do so, select the cell and then click on Run key, and then followed by importing the data that are the seasonal water consumption, that is transpiration, actual evapotranspiration, and potential evapotranspiration, which are seasonal and calculated at a step of module 2. So we import them, and then we create output folder, a folder which helps to save the output, which is a result of this analysis. So we create 2 folders, which is a folder called beneficial fraction and adequacy, which helps to save efficiency or beneficial fraction and adequacy calculation. So we select the cell and then click on run. So the second step is then to calculate uniformity of water consumption, which is a coefficient variation of seasonal actual evapotranspiration. So we select the cell and then click on run. So this Python code does the calculation, also save the values in the created folder. The third step is to calculate efficiency or beneficial fraction, which is a ratio of seasonal actual transpiration over seasonal actual evapotranspiration. So this cell, the code does that calculation. So select the cell and then click on run, which will calculate at the same time, also save it in the folder created and also show on this page. And the fourth one is to calculate adequacy, which is a ratio of seasonal actual evapotranspiration over seasonal potential evapotranspiration. So select the cell and then click on run. And the final one is calculating relative water deficit. So click the cell again and then select the cell and then click on run button. So we have the relative water deficit, which is a difference of the ratio of ETA over the maximum evapotranspiration from 1. In fact, the maximum actual evapotranspiration can be calculated as 99 percentile of the actual evapotranspiration, or we can just take the potential evapotranspiration. In this case, we took the 99 percentile of the actual evapotranspiration. So module 3 is complete. Now we can check whether the data are calculated. So if we click on the data, so here we see 3 adequacy and also 3 beneficial fraction, which are calculated. Thank you very much for listening to this lecture video.